Kirchhoff's current law, also known as Kirchhoff's first law or junction law. This law is named after the German scientist Gustav Robert Kirchhoff. This law states that the algebraic sum of the currents entering the node is 0. A hydraulic analogy is sometimes useful here. For example, consider 3 water pipes joined in a shape of a Y. We define 3 currents as flowing into each of the 3 pipes. If we insist that water is always flowing, then obviously we cannot have 3 positive water currents or the pipes would burst. This is a result of our defining currents independent of the direction that water is actually flowing. Therefore, the water of either one or the two of the currents as defined must be negative. Consider the node shown in the figure. The algebraic sum of the 4 currents entering the node must be 0. We can equate the sum of the currents having reference arrows directed into the node to the sum of those directed out of the node. I1 plus I2 equals I3 plus I4, which simply states that the sum of the currents going in must equal to the sum of the currents going out. Consider the following example. For the circuit, compute the current through the resistor R3 if it is known that the voltage source supplies a current of 3 ampere. If we label the current through R1 as I dash, we may write the KCL equation as follows. Summing up the current flowing into the node, I dash minus 2 minus I plus 5 equals 0. At this point we know that 10 volt source is supplying 3 ampere. KCL shows us that this is also current I dash. Therefore, I dash equals 3 ampere. Substituting, we find that I equals 3 minus 2 plus 5 equals 6 ampere. Therefore, the current flowing through the resistor R3 is 6 ampere.